Welcome to Nikolay's genetics lessons, and in my previous video I explained about RNA folding and explained how dot bracket notation works in order to describe two-dimensional folding form of the RNA to a computer. So we feed this information which computer can understand instead of these graphs. And today what we are going to do, we are going to do reverse engineering. So we are going to convert this form of notation, dot bracket notation, into two-dimensional form of the folded RNA. But before I am going to do it, let me explain, especially for those people who didn't watch my previous videos about RNA structure, about different structures that can make, and we have a special names for these structures. For example, take a look. The first one is going to be a hairpin loop. Hairpin loop. Where we are going to find it? It is structure here, hairpin loop. Another one is here. Next one, internal loop, and it is structure here. Another structure which we call bulge loop. It is a structure here. And multibranched loop. Multibranched loop is a structure here. So you see 1, 2, 3 branches here. We call multibranched loop structure with at least 3 and more branches. Next goes stem. It is structure here, what we call stem, here, here, and also here, here, and here. And the last one, pseudonode, it is a structure here. We do not call it stem, but you see there are two loops which are connected, made a connection by pairing, and we call this pseudonode. Now let's do reverse engineering and convert dot bracket notation into two-dimensional structure of RNA. We have 1 and 2 different RNAs here, so we are going to use them as examples. We are using dots for unpaired nucleotides and forward parentheses for paired nucleotides. So let's start. As you see, we have 1, 2, 3, 4, 5 dots which specify unpaired RNA. So let's put 1, 2, 3, 4, 5 dots which specify nucleotides which doesn't make a pair. Then goes, as you see, 1, 2, 3, 4 nucleotides which makes a pair. So 1, 2, 3, and 4. And let's also specify that they make a pair. So 1, 2, 3, 4. So this 4 makes a pair. Then we have 3 nucleotides which makes unpaired RNA. Let me put them here. 1, 2, and 3. They make a bulge here. And then we have 4 paired nucleotides. 1, 2, 3, and 4. Let's show that they are paired. 1, 2, 3, 4. Then we have 3 unpaired nucleotides, and then you see parenthesis closes. That means that at this point RNA would fold on itself, so would go in the back direction. So 1, 2, 3 unpaired nucleotides, and 1, 2, 3, 4 paired. Then 1 unpaired, and 1, 2, 3, 4 paired, and 1, 2 unpaired. Finally, let's show all the connections. So let's connect all the nucleotides. and they're going to look like this. And all those which unpaired, we show connections outside. So this is unconnected nucleotides. So this is the structure we got. Let's specify the structure that we have here. First, it is going to be hairpin loop, which is here. Internal loop. This is structure here. And finally, stem. This is structure here. So one stem. And here is another stem. Now let's move to the second example. How many paired nucleotides we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's show them here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is paired nucleotides. So let's show also pairs here. Next, we see 3 dots, which specifies unpaired RNA, and then parenthesis closes. That means that here we have a turning point, and then RNA folds on itself. 1, 2, 3 unpaired nucleotides. Then 1, 2, 3 paired. Let me connect them. 1, 2, 3. Then goes 1, 2, 3, 4, 5 unpaired nucleotides. 1, 2, 3, 4, 5. Then 1, 2, 3, 4 paired nucleotides. Let's put them here. 1, 2, 3, and 4. Let's show connections, which going to be as follows. Then 1 unpaired nucleotide, let's show it here, and 3 paired, 1, 2, 3, and 1 unpaired. Let's also connect them, and the structures we see here is going to be hairpin loop. Then we have here 1, 2, 3 stems. And we have here bulge loop, which is here and here. So as you see, using dot bracket notation, we can convert two-dimensional form of folded RNA into dot bracket notation, and we also can use dot bracket notation in order to decode and make again two-dimensional structures of the RNA. And dot bracket notation is compact method to store such information to feed to computers, and we would be able easily store such information on computers, and it's not going to take a lot of storage space. And this is all for today. Subscribe and see you in the next video. Goodbye.